So I'm a little, one thing I want to begin with today is not many of you turned in the homework. So that's unusual for all of you guys. So it's obviously a communication thing. So I just want to check, were you guys that did not do the homework, were you not aware that there was homework? Or did you have trouble getting that on Blackboard? So DJ, you're
I
shaking.
didn't even know we had.
Nick, say that again.
I didn't even know we had homework.
Okay, so
I thought it was just the jug.
Yeah, you're still working on your juggling. So at the end of last class, I said you had a conceptual sheet that was on Blackboard. Some of you did it, only a few of you did, most of you did not. So I want to give you some time. We're going to do that. That was my goal today, was to go over those questions that kind of just solidified what we talked about with momentum and impulse. So put some you working on it. So we're going to go over that. But on your Blackboard, because it had an assignment and a due date. I thought you had like a list that said what's due and when, and it kind of like flashed at you. Matthew, is that not the case on Blackboard?
There's just a bunch of a list of like assignments from like and there's also like drop boxes for like things that you need to turn in.
So,
that's
yeah,
under the assignments.
That's my question, because it should have fallen under Dropbox assignment due.
It was.
Okay. So all of you guys, make sure you are checking that all the time. If I'm going to grade it, make sure you check Blackboard. Now, the homework for tonight, here's how this is going to work, because so many of you did not do today's work. I have another assignment for tonight. I'm not going to put up another Blackboard site opening for it, but tonight's homework will count for all of you that didn't do last night's homework, and I'll merge them together as one assignment. That doesn't mean those of you guys that did today should not do the past, tonight's homework. It's just, I'm not gonna, I wasn't one that graded your homework all the time. It was more to lead and to help with class discussion and cause you to come in with some questions. So I just kind of want to continue with that, but I want to encourage you to make sure you're always checking Blackboard. Okay, Ryan.
I thought we were showing you the homework.
Well, that was going to be my question. Anybody who has it, you can just hold it up to the screen. So if you did not submit it to Blackboard, go ahead and do that. Ryan, is that what you were going to do?
No.
All right. And then what I need to do is pin your screen. All right. All right. Hold it up there, Ryan. Okay, very good. So I will give you credit.
Miss Risenweaver.
Anybody else want to do that? Yes, Chase or Hector.
So the homework for tonight, the people who did the homework from last night don't have to do it, or do we still have to do it?
You still want to do it because the purpose of your homework is to learn it, right? So yeah. I've said that all year. It's not about me. It's not about getting the grade. It's about you learning. You'll find, actually, we'll probably get it done in class today. The sheet that I'm thinking of, the next sheet, it might be more of a reading that I'm going to have you guys do.
Okay.
So let's see how class goes. I think it's going to go much quicker for you guys.
Mr. Risenweaver.
Okay, is anybody else? Matthew, you want to show me work, or I think you turned yours in.
I turned it in at like.
Yeah.
Yeah.
Did you get mine?
John, I'd have to go back to my Blackboard. Did you submit it in Blackboard?
I did, but it's right here if you just want.
If you turn it in the Blackboard, you're good. You don't have to show it to me live.
Okay.
Matthew, did you have another question?
Oh, no.
No?
I was just.
All right. All right, Nick, what do you got on this morning? Some good game from 12 years ago? A good playoff game?
No.
All you sports fanatics, have you seen the marble competition on ESPN?
Yes. Did you see
Oh
that?
my gosh.
Yeah.
How
Actually-
funny is that?
That's so.
It's actually, it makes me think of our marble challenge in class, right? But they have, if you haven't seen it, they have like these paths of wood. The marbles go over sticks and they like tracked out this path. It actually is pretty entertaining. I think what's most entertaining is the commentators, naming each marble and the color of them, and it's kind of funny. Makes you like feel like the marbles are alive. So if you haven't gotten a chance to see that, that's funny. All right, Nick, can I have you lead us in prayer this morning?
Okay. Father, Son, and Holy Spirit. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now and the hour of our death. Amen. Father, Son, and Holy Spirit.
Thank you. All right, gentlemen, let's have a great class today. Mustard seed for today. Okay, let's go to our mustard seed. Let's see. Whoops, I want to do that. Okay. So mustard seed for today, April 7th. God bestows his wisdom upon men and women in the classroom of silence. May silence become a great friend of yours. So we're all finding ourselves in much quieter places now. So maybe it's a good time to let God in a little bit more. So, all right, good mustard seed for today. What I would like to do now, the homework for today. So what we're going to do is I'm going to go over these, and they're quick ways to answer the questions. But at the same time, what I really want you guys to focus on is using the right words when we are answering these questions. And what do I mean by the right words? Impulse, momentum, increasing force, increasing time, change in momentum. So I want you to use the physics word, okay, what we're learning. And because, of course, we're just starting this, but of course, it gets maybe a little bit more difficult. So let's go back for a quick review on what do I mean by all that. So we started with Newton's second law, where the net force equals mass times acceleration. Okay, I want you to appreciate that we did that, and that was taking place in a moment of time, right? As soon as force was applied, that's what we would see in that moment of time of that force. So now we're putting time as a factor into there. What happens when time is moving on? So what we did is we took a look at the definition of acceleration, and we said it's change in velocity over change in time, right? So from that, then, we wrote the equation like this, that force is equal to mass times delta V over delta T, which led to force times delta T is equal to mass times delta V. Whoops, delta V, not P. Okay, this equation is now how we're looking at Newton's second law. It allows us to put time into it. So we're not always looking at a moment, an instant, we're looking at time. So I saw yesterday we were talking about in your book, they talk about an interval. This would be your interval. Over here, change in velocity will cause a change in momentum. So remember that P is equal to momentum. So this is momentum. And force times the time interval was our impulse. Okay? So if I do this, I cause a change in momentum, which means I cause a change in velocity. That change can be speeding me up. That change can be slowing me down. It could stop me. It could start me. So all of those things. All right. So what I would like to do now is we are going to do a screen share, which will be for those of you that did your homework. Very good. What I would like to do is be prepared to unmute. Good morning, Tucker. I get to see your face finally. All right. So when I call on you, just hit your unmute and answer the question. And then what I'm going to do is I'm going to type the question onto the document. So if you need to change your answer, by all means, go ahead and do that. So if you do not have the sheet with you, if you don't have your homework, you can write these answers down on a piece of notebook paper, but I will be sharing my screen to show it to you. Just know that this document is in the class document, so you can pull it up for yourself, okay? All right, so let's see. Okay. So we're gonna do a shared screen, go back to this. Okay, thumbs up. Is everybody seeing the worksheet on the screen? All good? All right, let's go through this quickly. So I will work through each of the questions and call on you, and we're going to type into what we see here. All right, so again, this document was what was due today for homework. So as I said, many of you did not have that. So often I will have the blackboard, showing the documents. So the other side of that is every day you can look on Blackboard. I'll have the day's date and it says you what the assignment is. So I am doing all of that through the course documents. All right, so let's begin with John. Number 1, which has greater momentum? A moving
The
skateboard or the
skateboard.
truck? Skateboard, why?
Yeah. Because it's moving.
Correct. The truck is
At rest.
rest, so it has, you could say even a fly would have greater momentum. So even though mass will make a difference on your momentum, the more mass you have, the more momentum you have. But the only reason you would have 0 momentum, because all objects have a mass, is if you have no motion, okay? So momentum is the result of an object moving. If an object is not moving, it has no momentum, okay? So to give an object to change its momentum, as we've talked about back here, you're gonna have to apply a force, but now we're gonna talk about that force really being an impulse. So instead of me saying I have to apply a force to cause a change in motion, we now want to say we have to apply an impulse to cause a change in momentum, okay, which is a little hint on number 2. Okay, number 2. Matthew, what did you say for number 2? Distinguish between force and impulse. Matthew, you might still be muted. There we go.
Force is what makes an object go into motion. Impulses like changing momentum, right?
Very good, I like that. Force makes an object go into motion. And what we would say here is causing it to accelerate, right? Making a change in its velocity. Whereas for impulse, causes a change in momentum. It takes into consideration time. Both are vector quantities. Okay. So when we talk about impulse, we want to include time. So I want you to be aware that time is included in impulse, whereas force is a moment in time. You don't have to consider how long the force is being applied. It is going to cause an object to accelerate, which means it's going to cause an object to change its velocity. Both are vector quantities, are the main things I want you to understand between force and impulse. Okay, 2 ways to increase impulse. Okay, for this one, I'm just going to write down here that impulse equals force, right, times delta t. So writing that very big, using it as a Word document here. Okay, so since impulse is equal to force times delta t, obviously, how do I increase? So I have 2 options here. Hector, what do you think? How can I increase my impulse?
Increase interval or increase your force.
Okay. F or delta t, right? So in your textbook, they call that the interval. So we talk about that as being the time interval. Okay, one or the other. So to increase impulse, you want to increase your force, or delta T, or both. So I have an option. If I want to change the momentum of an object, I can apply a greater force, make something stronger so it applies a greater force, or I can apply that force over a longer time period. Okay, so up here, where we just answered that, if I keep the force constant, so in this equation, impulse equals F times delta T, right? So again, I want you to answer these questions in terms of impulse momentum. So in this case, we can go back to saying, since impulse equals force times delta T, right? Why does the long barrel of a cannon cause the cannonball to come off faster than the short one? What in terms of impulse did we just change here? Tucker, what do you think for number 4?
I think that we changed the momentum, right?
Okay, so, well, both will change the momentum of the cannonball.
Yeah.
Okay,
But there's
but
the
the long one,
has more velocity.
correct, why? Of these two quantities, what did we do? So this has to stay constant. If I want to change the momentum, I have to apply the impulse. But they both have the same amount of gunpowder in them to cause the explosion, same size of a cannonball, so mass is constant.
It's something that it's just like guns, right? Like a longer gun shoots further than a short gun.
Correct.
But
If you're a hunter and you have a rifle or you shoot a rifle, the barrel of a rifle, the length of that matters on how fast the bullet's going to come out. So look at the screen as I'm working here. The longer the barrel, what am I doing?
does it have more chance to rotate?
Well, look at the screen. What am I doing?
Increasing
Increasing what? Quantity.
time.
Time. Very good. So what the longer barrel does in a rifle and in a cannonball or anything else, if the force is constant, which it is because you only can cause so much of an explosion. I can add more gunpowder, but because of the size of the cannon the cannon and stuff, we assume that we're putting in the same amount of gunpowder to cause the explosion to take place. Now that force is going to be applied over a longer distance. So imagine that barrel, and you're going to apply that force over a longer distance before you allow other forces to come into play, air resistance, gravity, and so on outside of that barrel when it goes into free fall. So both will change the momentum of a cannonball, meaning both cannons, but the long cannon, right? I'm going to keep that like that. Whoops. Let's go ahead and will allow the force to be applied over a longer time period. Okay. A greater time means a greater impulse causing a greater change in momentum. So remember that impulse, as we said at the beginning, causes a change in momentum. So I know you guys are aware, you know, it seems like, oh, this is common sense, what's in our world. That is true. You're used to these experiences. So I'm going to make that delta T a little bit bigger. Okay. And I want to say both cannons, not meaning both quantities of force in delta T. Okay, quick thumbs up. We good? Going too fast, too slow? Just right? Thumbs up if we are just right. Time to write down. Everybody doing okay? All right, so you can see I want you to, use the terms. You guys are doing great. Let's go back over here. Okay, number 5. Let's see. DJ, how is the impulse momentum relationship related to Newton's second law? I'm going to slide to the side. Here's your hint. My whiteboard behind me if you have me on speaker mode.
So acceleration is
Let's see. I think we lost your voice there, DJ. All right,
when-
DJ, I think we're having trouble hearing you.
yeah, my internet connection is really bad. So,
That's okay. Okay, we'll try one more time. I heard you start to say acceleration is.
acceleration is time over velocity or velocity over time.
Correct. Perfect.
And then momentum is mass times velocity, and impulse is force times delta t.
Excellent. Okay. So putting that in writing exactly as I have it on my whiteboard, and as DJ just said, in Newton's second law. So what you would write in here. Right? F equals ma. Acceleration A equals delta V divided by delta T, right? If we change that, and I can do an insert of an equation, but there we go. And then for impulse momentum, we have F delta T equals M delta V. So very good. So again, we haven't changed anything. We didn't come around and throw out Newton's laws. That is still holding true, right? So we just added to it in order that we can look at more things physically in our world in a different way. So collisions and things like that, explosions, they're really hard to evaluate. Momentum and impulse allows us to take a look at that in a different way. Excellent. Okay, number 6. To impart the greatest momentum to an object, should you, exert the largest force possible or extend that as long as possible, or both? Garrett, what do you think for that one?
Can you repeat that, please? Sorry.
Number 6, if you take a look at number 6. If I'm going to, so there's my hint. I wanted to put that equation back down. If I want to cause the greatest change in momentum, right? So remember that change in momentum equals impulse. And I do that by applying a force over a time period. So if I want to cause the greatest change in momentum, should I apply the largest force, the longest time, or both?
No, just force.
Just force? Okay, so since these are multiplied together, right? If I want to make that bigger and I have 2 times the amount of force, so if I put that as a 2 in there, right? If I say equals 2 F delta T, right? That's going to increase my impulse, right? Because now I have a factor of 2. If I have double the force, Would changing delta t, Garrett, also make that bigger? Let's
Yes,
say
ma'am.
I put a 2 in there again. If I have 2 times delta t, now altogether I'm going to have 4 f delta t, right? So yes, increasing the force will cause a change, an increase in my impulse, because I'd have 2 times as much. Increasing my time would also cause a greater. So 4 times is much bigger than 2 times, is also bigger than just 1, right? So doing both actually is the correct answer here. So both is what you want to say. Both will cause the greatest change in momentum. So I should say changing both. Okay?
Mr. Rosemuller,
Yes.
if a question asks like, which one would out of the two, which one would cause the greater? Like, if you had to choose one, which would it be? Or
Okay.
would they do the same?
That's a great question, Tucker. Very, very good question. Because they are both being multiplied together, right? If I change them both by the same amount, it's going to have the same impact. So if my choice is to double my force, I will double my impulse. If I can double my time, I will double my impulse. However, if I can only double my force, but I can quadruple my time, then time would have a greater effect. So that all depends on the situation. So you answered the question about the cannonball up here. That's a great example. And the designing of rifles and things, because the gunpowder limits the amount of force, the choice to make the barrel longer has a greater effect because that allowed me to put in more time because I couldn't control the amount of force and make that even more.
Okay.
Does that answer your question?
Yeah.
Yeah, that's a great question. And it actually then comes back to us physically, right? Which will be the last few questions on here. I am only physically so strong. I can go and lift weights, which I hope you all are still doing. I got my barbells out, trying to keep my body in shape. I realized I'm sitting a whole lot more than I used to, but I'm only so strong, right? So when I go to play sports or anything, often in sports, what we try to do is increase the time. So as you kick that football, the length of time that your leg is in contact with that ball is important, right?
Mm-hmm.
All of those kinds of things. So because now you can hit the weight room and change the strength of your leg, which changes the force, but in the end, putting a time factor in there is the easier thing to do, I guess I could say, sometimes. So that all just depends. A great question. All right, do a quick gallery view here for another check-in. I know it's such an exciting class. Roth, you still with me? You good? Okay. Chase, all good? All right, any questions? Everybody following along all right? Pay attention to our time here, got plenty of time. All right, number 7, following the same thing. So most of these questions at the end kind of go with your question that you had, Tucker, there. So if I'm going to have to do something, so if I'm struck by a truck or a moving object, and let's make that moving object the ball or something. So I'll go back to my challenge at the end was to have a water balloon toss or an egg toss, right? So if my job is this is going to hit me, right? So when it hits me, is it favorable that I catch this over a short time or a long time? So no matter what, I'm going to change its momentum because it's moving and then I have to stop it. So in this scenario, I want you to think of something hitting you that when it hits you, your job is to stop it. So the change in momentum is to go from a high momentum to 0. So I'm going to have to cause that change by applying an impulse. So again, if our impulse is the result of force times time, since whoops. It is hitting me. What do you want? Ryan, what would I want in this case? Do I want a big force or a little force since something is hitting me?
You want it over a longer period of time because if the force is coming at you, then if it's longer, then it's like more of an impact. Well, it's not more of a. It was still a bigger impact, but then you could like you're still absorbing that hit, and it's not taking as long. But if it's over a short period of time, it's like smacking you, and then you'll like after that, then you'll feel it more.
Okay, I like what you said there at the end. You'll feel it more. So since it's hitting me, you want the least amount of force, right? But you still have to stop it and change its momentum.
That's why, like in fighting, like boxers,
Yep.
instead of they hit you like it's like fast and quick, so it's not longer, so it can hurt more.
Very good. So that's even in number 9. What does it mean by to roll with the punches? And we'll talk about the boxing gloves too, the importance of that on your hand. So impulse. So I like how you said all of that. So since it is hitting me or you, since it's hitting you, I guess I should be consistent. This is where my poor Western Pennsylvania grammar comes out. Since it is hitting you, you want the least amount of force, but you still have to stop it and change its momentum by applying the force over a long time period. You can cause same change in momentum. So no matter what, the change in momentum is going to be constant. It's moving, I have to stop it. So that change in momentum, let's say, is 10 Newton seconds or kilogram meters per second. I can do that with a value of a 1 Newton force over 10 seconds, or I can do it with a force of 10 Newtons over 1 second. And those are your 2 scenarios that you can have. 2 and 5, many numbers add up or multiply together to be 10. But very good. That's what you mean there. So in some cases, you want a small force when you cause that change in momentum, right? In other cases, like in number 8, right? I do want a big force because my objective is to break it. So if I want to break something, I want as big as a force. So in this case, since you want to break the object, right? In a karate chop, since the goal is to break the object upon contact, you want the largest force possible, right? So to have the largest force possible, in this case, let's go back to John, trying to pay attention to who I'm talking to. Since we're trying to break it and I want the largest force, what kind of impulse? What should I do with force and time? So that's the number 8. Why is the force that is applied for a short time more effective in a karate chop?
Why is the force that is applied for a short time more effective? The average force is increased.
If my time is, so you have to add to that.
Short, long.
If I go back up
Short
here
time.
to impulse, if this on the left side has to equal 10 and I make this only equal 1, my force would be 10. But if I make my time longer, like 2, my force went down to 5, right?
Yeah.
So
it's short.
yes.
No, it's longer. No, it's
Now
short.
You want short time, right? So since the goal
Yeah.
is to break the object, you want the largest force. To have the largest force for an impulse, you want the shortest time. Right? So they have the largest force, you want the shortest time. Okay. Give you all a second to write that all down. Hopefully it's making sense. We are now kind of repeating ourselves. So 9 and 10 go similar to 7 and 8. So in number 9, chase. Why is it advantageous to roll with the punch in boxing? You might still be muted, Chase.
When you're doing the when you're like going with the punch, if you punch someone and like you're extending the interval if you roll with it. So instead of it just being fast and quick, you're also extending the interval, so making the force have less of an impact.
Perfect. Exactly. So I like exactly how you said that. So same as number 7, right? Similar to number 7. By rolling with the punches. Excuse me one second. Okay, by rolling with the punches, you are increasing the time interval of the force being applied. The force is small for a large time. Very good. Okay, by rolling with the punches, you are increasing the time interval of the force, right? Making time big, but force small. All right, in number 10, let's go Joseph. Haven't heard from you yet. What do we say in number 10? Did you have a water balloon toss?
I did not.
Oh, you need to get John out there and throw a water balloon at him.
I don't have any water balloons.
Oh, well then you have an egg? We'll go dangerous and go with the egg.
I don't think my mom would appreciate us wasting eggs.
Oh, okay.
Because that would definitely go wrong if we did eggs.
Especially now when we're all avoiding going to the grocery store. I appreciate that. See, I always just have balloons in my hand. I have to tell you, one of our favorite activities at Easter is we always have about 50 people at our house, and we have a big egg toss and water balloon toss.
Oh, that's sweet.
Usually get a good 50 yards apart with both of them and can still catch it. It's actually so much, it's turned into quite a tradition. We're going to try to do it over Zoom this year. We'll see. All right, so Joseph, if you went out and had a water balloon toss and an egg toss, how would you catch it?
You would kind of want to like move your hands down or like back with the ball with the water balloon to make the time interval like a little bit longer so it has less impact.
Excellent. Very good. So that follow through, right? So in these last scenarios, I'm going to go ahead. We got the same situation here. I'm just going to paste it right back. Same answer. Very good. So in this case, right? Whoops. Oh, look, it's giving me like I have a number there. Similar number 7, right? Instead, the rolling with the punches, when catching, pull your hands back with the balloon. You're increasing the time interval of the force being applied, therefore the force is small for a large time. Okay, excellent. So we saw a lot of the similar answers, right? Repeat it over and over again. Hopefully it's stuck in your head. Those last couple answers, water balloon, catching it, right? So I always laugh when the person, you get all excited and you run into it. right? So somebody, when they're trying to catch it and they run into it, that's even worse because you're going in one direction, the balloon coming in the other. That's actually the worst kind of impact. That's true in a car accident. You know, if you see a car coming from behind you and they're going to hit you, if you can, the best thing is for you to move forward with it. You're doing exactly the same thing and you're increasing the time of that impact. A lot of people get nervous and they slam on their brakes, so they hold their car steady while this car comes in and hits it. Well, that's going to increase the force of that car coming from behind hitting you. That actually happened to me last summer. I was hit from behind, so believe it or not, that car's been hit twice. So parking lot of Benedictine, but also from behind, and that's exactly what I did. We were stuck in traffic and I saw this car coming. I knew she wasn't going to stop, so luckily I was able to swerve out and move forward while she hit me. So it was still a lot of damage, but not as much as it would have been because I allowed her car to be in contact with me over a longer time. Certainly not what was going through my head, but afterwards I can think about that. I knew that, you know, that would be the case. So same thing if something's coming this way, if I want to stop it, if I just hold steady and it hits me, you can imagine that amount of force is much higher because my time is lower. Whereas if I give with it, right, catch it. All right, any questions from you guys? Let me unmute you all. Questions, comments? Everybody hanging in there?
Yes, ma'am.
Okay, sounds good. All right, for fun, some of you sent me videos, so I made it extra credit that if you go out and you do have a water balloon or an egg toss, to send it to me, because you know me, I don't like to just tell you all of this information. I want you to experience it and think about it and apply it in many, many situations, so in your sports and so on. So let me go back to another screen share with you all. And let's see, who sent me one from this class? I don't know if I got any from any of you guys catching the egg. This is one I'm going to share from Graham Martin. So I got a couple. Oh, no comments. He did pretty good. Wait till you watch. And the reason I want to show it to you is because of what happened when he was doing it. All right, so I'll put you all back on mute and we'll watch this video. I'll go back to the screen share. All right, let's see here. Share my screen. All right, y'all watching? Everybody see it? Okay, if we go back to the beginning, or back here. So slowly there, right there, right? Where is his hands? Way underneath him. Where did they start? Right, if I go back a little bit further, way up high, up here. So he, through that whole time frame, caught it. So Joseph, perfect answer for your answer to that, to pull your hands back as you are catching it. But let's go back to a discussion here. All right, so again, somebody tell me, why did it not break when it hit the ground? Ryan.
He calls an impulse when the momentum of the water balloon came, and with his hands he calls an impulse of bringing them down to absorb or create less force from the ball.
Okay, so when he was catching it, so if you saw at the beginning though, his dad didn't throw it far enough. And so it landed way in front of him right on the grass and it didn't break. So what was the purpose of the grass? Or why didn't it break in the grass? Ross, what do you think of that?
What was the question?
Why did the egg not break in the grass?
Maybe because he already Like, because he already decreased momentum by going down with it, therefore there was less force.
Well, Graham never touched it. So
I don't know.
before he caught it, it landed in front of him in the grass. And his dad Graham said, "Oh, it didn't break." And his dad said, "You're kidding." And then, of course, he said, "I'll throw it back to you." But his dad said, "No, I don't want to catch it." So it was smart on his part. But what happens in the grass? Roth, I'll go back to you.
It's because the grass is soft.
Okay, and what do we mean by something absorbing, something
Yeah.
soft? So in terms of physics, we are increasing. What does it mean by being absorbed? What quantity do we increase?
No.
Magnitude.
Time or force?
Force.
Time. Now,
Yeah.
if I say I'm absorbing something, airbags, bumpers on a car, cushioning. Ryan, your football helmet. What's the purpose of that football helmet? To increase the time of impact, right? You have cushioning in there. It's all designed to increase time. So what becomes minimal if you increase time? Force. What hurts us? Force. So all of that equipment that we wear, safety protective equipment, the equipment in our cars, we know collisions are going to take place. So if we want to make sure that the force is minimal, we want to increase time. Now, Jacob Shively sent me a video. I don't want to take the time to pull it up. But his sister threw the egg too far, and it went way over top of his head and landed on the driveway. So his egg landed on the driveway. Graham's egg landed in the grass. Graham's definitely survived. The one that landed on the driveway, of course, did not. DJ, what happened when the egg landed on the driveway in terms of impulse, force, and time?
It was a sudden stop, so it just like reverberated through the egg, smashed.
Okay. Well, instead of saying reverberated, or what happened to force because time was so small?
It was large.
Very, very big.
Yes.
And what happens to the egg when the force on it is too big? It breaks, right? But the egg landing in the grass, you increase time and force became very small, right, Ryan?
Can you apply momentum or impulse to like when somebody throws a water balloon at you, but it doesn't like break?
Absolutely. So now if you make the balloon very firm, right? Like this balloon, it's a big balloon, but I didn't put a lot of water in it, so it can give. So what do we mean by that give? Same thing. When it hits something, it'll give. So when anything is cushioned and it gives, you apply the force over a longer time, right? But if this was really tight and harder, there wouldn't be much give, so there'd be a lot of force. And it's that force that's going to cause something to break. So yes, when you play, and you're throwing water balloons at each other, somebody running away from you and the balloon hits them as they're running, they're kind of going, it usually doesn't break very much. It's when they're coming toward you and they're trying to throw one at you and you get them as they're running towards you, that's going to cause a big impact because they're not taking in more time. Does that make sense? Yeah. So if you want to have a water balloon fight, challenge the person to come, when they're coming after you, be brave to hold your ground and throw the balloon at them, as opposed to when they're running away from you. Some of your physics. All right, since you're asking about sports and stuff, because I know you guys love your sports, the same thing is in the opposite. Now the balloon or the baseball, the football, whatever, soccer ball, volleyball, the best one, is at rest and I need to get it moving. So Tucker, going back to your question at the beginning, I'm only so strong, so I can only apply so much force. So the way I make this ball go faster is I need more impulse. So we no longer want to talk about just the force. We want to say that I need more impulse to change its momentum. So now I'm going to have to apply that force over a longer time. So for me, with the volleyball players, if they're hitting the ball, I want their arm to contact it back here, and they're going to be in contact with that ball for a long time in order to allow the greatest impulse on it. So why do I want the greatest impulse? Because that means it's going to change its momentum the most and become faster, right? Okay, kicking a ball. As we said at the beginning, Tucker, when you kick and your foot is in contact with that ball for as long as possible, gives you the greater velocity for it to come off. Sometimes you don't want that. In baseball, right? If I'm bunting, I don't want the high velocity. So it's a quick contact. Why do I want a quick contact? Because I want the time to be as small and force to be as small, so I don't cause a much of a change in momentum. But if I want to hit the home run, you better believe I'm going to follow through as much as I can, right? Do I know my sports?
Yes, ma'am.
You can always, I used to love bringing physics into my, in the gym when I was coaching. That was fun. All right, any particular questions from you guys? I am well over time. Holy cow. I apologize. I didn't realize I was going over time.
We have an hour.
What do you mean we have an hour?
No, I'm
Mark.
saying
I wish I had
till next class.
You're right, you have lunch. We should have lunch together someday. Oh.
Look, they all left.
Okay,
at 10.
before y'all log off though, there is homework tonight, which is now putting numbers to everything. So
Two
get
people
online.
left.
It's called Plug and Chug. That's your homework. If you did not turn in yesterday's homework, I want this homework turned in on Blackboard under the conceptual question. I'm going to rename that on Blackboard, and your Plug and Chug is also due. Okay?
Ms. Rosenberg,
What about for the
Yes,
people
right.
who did it?
Did
If
you
you
give
already
me-
did the conceptual questions, I have that as a grade, and it's not that you don't have to do the Plug and Chug, you just don't have to show it to me. Tomorrow, I'll have you hold it up to the camera and just show me that you completed it.
Did you get my conceptual thing? Because when I turned it in over the weekend, it wasn't like, or turned it in yesterday, my Blackboard was like messing up.
I didn't have many from this class. I didn't write down exactly who turned it in, but if it's showing that it turned in for you, it should be in. But check Blackboard. I'm not on it right now.
All right. Can
So I
you
can-
send me an email if it is? Because then I'll just turn it in.
Yes, I will try to look after. Yep. Ryan?
Send me an email of it.
Did you count that for my credit? Did you give me my credit?
Yes.
Okay.
You got credit for it.
Yes, ma'am.
Okay. Any other questions from anybody?
No, ma'am.
Nope.
Thank you.
Have a great day. Can't wait to see you Wednesday. Our last
Thank
class before
you.
spring break.
Bye.
All right. Take care. Have a great afternoon.